Okay, hello everyone. So in this video I'm going to solve easy integration by substitution problems in exercise 4. So how you can use this video is try to pause the video, try to do the problem by yourself and check with my answer if you get it correct. If you got it correct, perfect. But if you got it wrong, no big deal. You can watch and learn how to do the problem correctly. Alright, so with that let's get started with the second problem. First of all, identify the inside function. So the inside function here is x square minus 1, right? So it's inside the parentheses. So I decide my u to be x square minus 1. Now take its derivative, write it somewhere else. So derivative of x square minus is 2x minus 1. Is it 2x? I'm sorry. So can you see 2x somewhere else? Absolutely yes. So we can use integration by substitution. So my u is x square minus 1. Let's write du over dx. Do not forget that always there will be two substitutions. So derivative of u with respect to x is 2x. So that means dx is, do this step carefully, du over 2x, right, by cross multiplication. Alright, so let's replace these two things. Again, integration by substitution is always about replacing two things. So 2x, here it's u to the 5, dx is du over 2x, and see this simplification by yourself. So 2x cancel out. Okay, so what we get is integral of u to the 5 with respect to u. So if you integrate u to the 5, you get u to the 6 over 6 plus c. Okay, so let's replace u is x square minus 1. So x square minus 1 to the 6 over 6 is the integral, is the solution of the integral. Okay, right, so let's do this third problem of the exercise 4. This is a easy one. Sine 3x, sine 2x, my bad. Now sine 2x, we all know how to integrate this from basic integration rules, right? In case if you have missed that, click on the link above and watch and learn. Now I didn't show it in when we are doing integration by using basic integration rules at that time, because we can remember it, right? The rule is divide by 2, so it's half. Integral of sine is negative cosine, so this is the answer. But really the rule came from integration by substitution. How? Let's see it. What is the inside function? 2x, right? So u is 2x. What is its derivative? 2, a constant. So well, we have a constant here, it's 1 times sine 2x, so it's fine, we can use integration by substitution. So du over dx is 2. That means dx is du over 2. So let's replace. So here sine u, right, dx is du over 2. So it's just you are integrating sine u over 2. So if you integrate sine, what do you get? Negative cosine u, and this half comes with it, right? It's a constant multiple. So what is u? 2x. So we get the same thing as what the rule says, the basic integration rule says, right? So that rule is created out of integration by substitution. Okay, so I just wanted to show you in this video. All right, so let's not do question 4 in the exercise because it's similar to this one. Let's do fifth one. We want to integrate e to the x square root 13 minus e to the x. Okay, what is u? What is inside function? Inside square root you have 13 minus x, right? So that is my u, 13 minus x. Now what is its derivative? Derivative of 13 is 1. Derivative of negative e to the, derivative of 13 is 0. I am very sorry. Derivative of 13 is 0. And derivative of negative e to the x is negative e to the x, so it's negative e to the x. Okay, so do we have negative e to the x somewhere? We have e to the x but not negative, but do we care? No, it's totally fine. So still we can use integration by substitution. So let's use it. Okay, so du over dx, derivative is negative e to the x, so dx is du over negative e to the x. Alright, take that negative also to the other side. Okay, alright, so if you replace here e to the x, square root of u, right, 13 minus e to the x is u, dx is du over negative e to the x. E to the x cancel out, So what we have is really negative square root of u, right? Square root of u is u to the half. Now if you integrate u to the half, what you get is negative comes outside, that stays outside, half plus 1 over half plus 1 plus c. Okay, so half plus 1 is 3 over 2, divide by 3 over 2. So division of 3 over 2 is actually multiplying by reciprocal. So reciprocal of 3 over 2 is 2 over 3, negative u 3 over 2 plus c. Then we can, let's write the final answer here. Let's replace u by 13 minus ex. So negative 2 over 3. U is 13 minus ex to the 3 over 2 plus c. So this is the solution. This is what you get if you integrate, if you solve this integral. Okay, let's do problem 6. Alright, 2 more problems to go. So t cube square root t to the 4 plus 5. Now we have a different letter, but don't worry. What is the inside function? U is t to the 4 plus 5. Now what is its derivative? 4t cube, right? Do we have 4t cube somewhere? We have t cube somewhere else, but not 4. But it's okay. So we can use integration by substitution because we at least have t cube. Let's take du over dt now. Okay. Now if derivative of t to the 4 plus 5 is 4t cube, then that means dt is du over 4t cube. Okay. Take that 4 also to the other side. Okay. Alright. So let's replace. Here t cube and here u. Dt is du over 4t cube. So we can see t cube cancel out. Then what we get is actually square root of u over 4 du. So this is same as u to the half over 4 du. So if you integrate, so let's take 1 over 4 outside. So you just integrate u to the half. So if you integrate u to the half, it's u to the half plus 1 over half plus 1 plus c. Half plus 1 is 1 over 4, u here 3 over 2, divide by 3 over 2 plus c. So division of 3 over 2 is same as reciprocal, multiple reciprocal of 3 over 2. So 1 over 4 multiplied by 2 over 3, u to the 3 over 2 plus c. So 2 and 4 cancel out and produce 2 on the bottom. So that 2 here times 3 is 6. So u 3 over 2 over 6 plus c. Right, let's finish it by replacing u. So u is t to the 4 plus 5. So t to the 4 plus 5, 3 over 2 over 6 plus c is the solution that you get after you solve this integral. Alright, final problem, a good one I think. Alright, so the final problem is integrate sine t square root 1 plus cosine t with respect to t. What is the inside function? U is 1 plus cosine t, right? Everything that is inside. Don't just take only cosine t, it's 1 plus cosine t, okay? So what is the derivative of u? Derivative of 1 plus cosine t is, derivative of cosine is negative sine t. Do we have negative sine t? At least we have sine t. So we can use integration by substitution. So the derivative of u with respect to t is negative sine t. So dt is du over negative sine t. Take that negative to the other side also. Just have what is dt. So then if we replace sine t, here it's u, dt is du over negative sine t. Sine t cancel out, so we have negative outside. Let's take that negative to the other side. We have square root of u. Well, we integrated quite a bit of square root of u's in this video, right? Okay, so square root of u is u to the half. So if you integrate, let me write it fast. This is u 3 over 2 and we divide by 3 over 2, but it's reciprocal multiple of 3 over 2, so it's 2 over 3 plus c. So the final answer is, what is u? 1 plus cosine t. So it's 1 plus cosine t 3 over 2 over 3 plus c. So this is what you get after you solve integral 7 in exercise 4. Alright, so these are easy integration by substitution problems. So in the next video, I am gonna catch you with medium level integration by substitution problems with more discussion. Okay, solving exercise 5. So you can go to that video by clicking the video that appears in here, and I will see you in that video hopefully. Until then, bye bye.